Alright, the dreaded Bakelite blocks that Philco like to use so much in their 30s and 40s radios. Let's do this one first, because it's the one that is currently disconnected. We've got room to work around it. This is the one that has the AC line filters in it. There's a bunch of ways to do this. One, disconnect the stuff inside or cut the lugs off and put external parts. Ugly, crude, it's not that hard to get the insides out, so don't do this if you can avoid it at all. No offense to anybody who has, but trust me, it's not that difficult to get the insides out. There's two basic ways to go about it. One is to disconnect everything and remove it and work on it and put it back in and reconnect everything. And the other is to try to leave everything attached and work on it in place. Typically in the past, I've disconnected everything. There's a couple issues with doing that though. One, you got to remember to put it back in the right orientation and hook all the stuff back up correctly. Yeah, reference photos help, but when you've got stuff stacked up, it's hard to get a photo from every single angle and remember exactly where everything went. Sure, the parts placement diagram helps, and if you've really studied the schematic well, and of course that helps too. Another issue is these old wires with their old brittle insulation. It's best to move them as little as possible. One trick that can help a little bit is if you got a heat gun or a hair dryer, if you heat these up a bit, they do get a little more pliable. What happens, or can happen, is if I flex this, if I was to bend this at a 90-degree angle, well actually you can see it's already happened back here. It cracks. The outer cloth covering is somewhat flexible, but underneath that is that gutta purchase stuff I talked about earlier. It's kind of like rubber. It's gotten hard over the years. You bend this, it just cracks. And then the cloth starts to unravel. You bend it a few times, you could even get stranded wire poking through. Now this wire is going to the power switch, so I'm not crazy about having breaks in it. And I'm sure I did that now that I look at it, because it used to go to this lug, and I disconnected it, and I wasn't as careful as I could have been, and I flexed it, and I cracked the insulation. I could slide heat shrink tubing over it to help protect it, or I could replace the wire if I had to, and then that has its issues too. Notice how there's a wire wrapped around this, snaking up. Sometimes it's just done to keep the wires in place, but sometimes it helps to reduce hum. Not just wires wrapped around each other, but the orientation. Some wires are run this way, some wires run this way. That can be intentional sometimes to reduce crosstalk and interference. Alright, so pros and cons of removing the wires and components. Problem with leaving stuff attached, of course, is it can be pretty difficult to get at stuff. So I thought we could start with this one because it's not too bad, plus I've already disconnected some wires. But you can see some of them, there's one underneath all this stuff. Alright, so the basic technique when you leave stuff attached is, well, you disconnect that 1/4-inch sheet metal screw which goes all the way through the block into the chassis, and whether you're going to remove it or not, you got to get the insides out. In order to do that, you need to disconnect these little wires. So there's a capacitor or two inside of each one of these blocks. And they run the leads from the caps inside this block up through these little eyelets. They wrap them around the lug and then they attach external components to it. Well, if we want to get these out, we need to break those little wire leads. Use a pocket knife, use a drill bit, or if you really want to be tedious about it, get your soldering iron out, heat up this blob and unravel it. Maybe use some desoldering braid or a solder sucker to get it off. Get these wires loose, get them disconnected. Then to get the insides out, well, if you completely remove it, you can work on your workbench. If you leave it in place, you can stick a tool down through these holes and push it out from this side. You're going to have to take that screw out, pull it away a little bit from the chassis, rotate it around a little bit, and poke through those holes and get the insides out. Put your new components in from the other side, get the leads coming out, wrap them around, cut off the excess, carefully put it back into position, put that screw back into place, and you're good to go. If you completely remove it, of course, you can work on it on your workbench, and you can, you know, get all the inside scooped out, put your new caps in, reinstall it, hook everything back up. Now, to get the insides out, there's a jelly roll of metal foil and paper. Probably 2 inside of this guy. They're encased in, it looks like tar, but Philco called it high temperature wax. I'm not sure which it is. It's black, it behaves like tar, basically. It's hardened and it sticks pretty well to the sides of the Bakelite block. I've heard some people put it in the freezer, which helps it shrink and pull away from the Bakelite, and then you can just poke it through if you're lucky. I've never tried that. What I typically do is heat it up. So if you do it in place, that's a little tricky too, because you don't want to heat up everything, and you start melting stuff and get wax running and so on. But you don't need to heat it up a ton. Try to get the heat on the sides to melt the sides a little bit, or not really even melt it. It doesn't have to get fully liquid, but just soften it up a little bit, and then poke it through, and ideally you just get a whole big blob that comes out. If you watch my old videos, typically I'd removed them, I get it on a workbench, I use a heat gun, and then I'd chip away at it with something like a screwdriver, toothpicks, whatever, and then gradually get everything out. So since this one, basically everything's disconnected already, and I want to really show you guys what's in these, this one I will completely take out and we'll dissect it. And then we'll try the other approach, maybe on this guy. Alright, let's get this cap out. I think all we've got attached to it Alright, let's get this cap out. And I already disconnected one of the sides, and we got this lug holding it to the chassis, and then we got our line cord coming in. I'm just going to go ahead and take this out so we can maneuver it. Hang on to this, and sometimes there is a star washer underneath. I think I might have just heard it slide down. You want to keep, yep, there it goes. And it just slid into the tube socket. You got to keep track of those, or you can very easily short something out. Ooh, wow, that looks really nasty on the here. Let me get this out. I'll give you a close-up and show you why you need to either disconnect or remove these. I'm really glad I didn't power this up with that in circuit. Alright. I think you can see one reason to disconnect these, and then all I do is twist this and the wires came right off. Alright, so these are the two caps right across the AC line to ground. Check that out. That has melted and they are split apart inside. There was definitely some self-heating going on with this. And I would not be... Ooh, and the side is cracked. Yeah, there was definitely some pressure going on inside this cap. This thing was ready to blow. Ooh, the side's blow. If I take the tower out, this thing's going to fall apart. This whole side's just going to fall apart. That is a drag. Well, so I can leave this out, but then I lose my mounting points for the wiring. So I will have to either live with that side being blown out. We'll take the insides out, see how bad it is. Structurally, it might still be okay, although there is a lug on the side that's blown out. That Bakelite may be kind of compromised. I can dig through my stash. I've got a few extras. Maybe there's one of suitable size that I could use. And so here's the part number embossed on the side. So if you're really, really hardcore about this, you'd want to find another 3793E to use. That's melted into the side. So you really can't easily take another one and kind of rebrand it. But you know, that's getting kind of kind of crazy specific. I mean, the only problem would be potentially if I swap this out with one with a different number on it, is a future restorer or repairer might dig in there and not have a schematic and look at this, and you can look up these part numbers and it'll tell you what the caps are inside, and if we replace one with a different number on it, that could trip somebody up. We could leave a note, we could just not worry about it, move on with life, we could sand this off, a lot of things we could do. Now, as far as getting this out goes, sometimes it's crumbly, especially if it's kind of deteriorated already like this one. You can just start digging it out. It's kind of hard to describe until you play around with this. It's not really sticky. It's not soft. It's actually pretty hard stuff, depending on what temperature you're at right now. It's about 75 degrees in here. It's not beeswax. I don't think I'd call it just straight up tar. It has a little bit of a tar odor to it. So there are plenty of times where I've just done this. Problem with this though is if you get to the side and you do something like this and twist it, you can blow out the sides very easily. A little bit of heat from a heat gun or hair dryer and this does soften up quite a bit, even at like say 120 degrees, 150 degrees, something like that. Not so hot that you can't hold it, and it does help. But the problem with heating it up is you generate a stench. Depending on the more hotter you get it, the more the stench, but the hotter you get it, the easier it is to get the insides out. Pros and cons. So another way to do it is, again, to either unwrap, unsolder these little wires or cut them and drive a corkscrew into this, and ideally pop it out. And I've heard if you freeze them, that helps considerably. I've never tried that before, so let's give it a go. Here it is, fresh out of the freezer. Now, I thought that a corkscrew would be way too aggressive for something this small, and actually the caps that are in here are so big they almost filled this entire void. So I thought I'd use a wood screw. Started driving in, and as soon as I did, the side busted out. There is like no integrity left to this block whatsoever, so there's just no hope in saving it. So I'll have to demonstrate techniques on another one. I'll go to my stash, and whether I have one I can use in this or not, let's try practicing on one of those first. But this is one of the very realistic issues that can happen if you just plug one of these in without even turning it on, because this is right on the AC line even with the radio turned off. So definitely check for these, disconnect them as soon as you can before you start plugging the radio in or working on it. Maybe not all is lost. It occurred to me, hey, let's pull out the heavily modified 90 chassis that I have that's currently in the cabinet that we're going to put this into, see what we can salvage. Also, it's an interesting little snapshot in history to see how repairs were done, how modifications were done back then. As near as I can tell, these modifications were done early 40s, maybe slightly after the war. So it's got octal tubes in it. I'm trying to remember when exactly they came to be into common use. Maybe we can find some date codes on some of these caps and date it a little bit better. I'll clip some of these out. So this thing was modified extensively. The front end is the same, so everything from here up, the RF, the IF, the local oscillator, mixer, this stuff is virtually the same. I see one cap has been added here and a little terminal strip doohickey. The rest of it looks the same, other than some parts looking slightly different. For example, this is your standard looking dog bone resistor. Over here, same value but different style with the metal end caps. And slight differences in the color of the wires and how they were routed, but the circuitry is the same. Oh, So starting from the middle down, we notice some drastic differences right away. Two big box capacitors here, completely gone. There are, I believe, 3 caps inside each of these boxes, so a total of 6. I'm not sure where they all went. A terminal strip was added. We've got 1 cap here, we've got 1 cap here, a couple big old dog bone resistors, a couple caps added way down here. I don't know. What I can tell you is the tubes from here down are changed, except I think the 80 rectifier is the same. But the output tube, the preamp tube, the detector tube have been changed. 6H6 for the detector. I don't recall what the preamp and amp are. I'll have to dig it up. That's probably a 6V6 or something like that. They're all octal tubes. They're all 6.3 volt tubes, which means they had to add a 6.3 volt filament supply. That's what this transformer that's hacked into this corner is all about. That's just the filament supply for 3 of these tubes. That's what these twisted wires are. Twisted, well, one, it makes the wiring look neat, but also it helps to reduce radiation of hum by twisting the wires together. These controls have been replaced, I do believe. Tell for no other reason than the shafts have been cut off, kind of crudely with a hacksaw on the end. Some coax has been used here and there. Strange looking power resistor added down here. This is a electrolytic, actually, or a 2-section electrolytic. Probably part of it, or both sections, I think they're connected together, is probably the cathode bypass on the new audio output tube. Speaker socket's been rewired. Filter choke is gone. Used to be here. I'm sure they're using this speaker, it's field coil, for the filter choke, and they just took this out completely, which probably would have raised the B, well, would have raised the B plus potentially a little bit, because I think the main reason I can see for doing all this is to get to more sound out and maybe higher quality sound out. The speaker that is in there is well, without hearing them, I can just go with what I read online, but it should sound better. This new output configuration has a little bit more power. But they didn't change the front end, so as far as selectivity goes, sensitivity, that would be the same, but it should have more oomph on the output. Heck of a lot of work, though. Considering when it would have been done. Maybe it was done during the war, you know? That hadn't occurred to me. Or shortly after, when parts were scarce. Otherwise, when I just buy a newer radio. Because this, I mean, he would have had to buy these parts and put a lot of time and effort into tinkering to make this thing work right. Also conspicuously absent is the big bias power resistor down here. That surprises me a little bit, because they still would have had to bias some of these tubes, and where would they get the negative voltage from? Maybe that's what this is all about. Okay, all that aside, what can we do? What can we scavenge? Oh yeah, one more thing, I almost forgot, they added an eye tube. A rather nice looking GE eye tube. I'm not a big fan of these. Philco never used them. They did use a shadow meter tuning indicator in some models, which serves the same purpose. But generally they didn't use any tuning indicator. I say I'm not a fan because I tune in a station by listening to it when it sounds the best. I don't look at a visual indicator. And given how they wear out, they're getting kind of scarce and expensive to replace. Yeah, they look cool. I'm going to argue that. But I can do without them. Most of my radios do not have them. But this individual did add one and cut a hole in the cabinet to add it in. At any rate, back to the plot. We have a blown apart Bakelite block that we want to replace if we can. It is a 3793E. Now all the Bakelite blocks that were in here are gone. There were 4, would have been 4 here, all gone. We got one left. This did not exist on here. There was a tube socket here that's been covered up. So let's see, originally it would have been here, that's gone, but let's take a look at what is this hooked up to. it is going to power switch. It's going to the AC line, so this could be that AC cap, but maybe it got relocated. Can't quite make out the numbers, so let's unmount this and see what we've got. We're in luck. This is indeed a 3793E. Even better, I've been posting a sort of a restoration diary online at the Philco forum. It's a resource I don't talk about enough. I talk about anti-radio forum, video karma, but there's also a website called Philco Forum, spelled P-H-O-R-U-M. I'll put a link in the description. It's run by Ron Ramirez. It is the be-all, end-all resource for all things Philco. Mostly radios, but also TVs and the history of the company and all kinds of great info. So they filled me in right away on two things. One, the speaker I have is from a Model 20, and it may possibly work in this radio, but it is inferior to the one that came with the 90. That speaker is even earlier than the one that would have come with the 90. The overall shape is the same, the cone is the same, but it would have had a better spider. That's the thing in the middle that kind of holds the cone in place over the voice coil and helps it move in and out. So I will still be on the hunt for a better speaker. Also, I was wrong. I'm not afraid to admit when I'm wrong. I don't know everything. The line filter does matter. And it makes a lot of sense once I was told why. So on the back of the radio chassis there are two jacks for the antenna. One just says antenna, it's insulated from the chassis, and that's where you attach your long wire to. The other one is ground and it goes right to the chassis. I don't have it connected. I usually don't. I have noticed in the past it doesn't seem to make a whole lot of difference. Reason is it's because of this guy. This will make a difference. Either you need to ground that chassis to a real ground, like cold water pipe, which eventually goes into the ground, or the neutral wire on your house wiring, or the ground terminal on an outlet, both of which eventually go to literally the ground. That's where this comes into play. As far as radio frequency is concerned, the capacitors in here are a dead short. They pass right through it. This is what provides the ground return path for your antenna. It goes through the AC line, through your house wiring, and into the neutral and into the ground. So having this makes a big difference, or should, or at least it should make some difference when I rebuild this and install it. So I'm going to do just this and nothing else. And we're going to see what kind of difference it makes. Because this whole time we've been playing around with this radio, this has been disconnected and we had no ground connection. And I noticed that the antenna didn't seem to be doing as much as I thought it would. In fact, when the radio was disconnected altogether, we were still getting reception, and hooking it up, I got a little bit better, but not like a huge difference. Alright, enough talking, let's get to it. So I'm going to show a few ways to do this. I'm going to do it first the way I've done it before and I've shown in the past, which in all cases we're going to start out doing the same thing. We need to disconnect the cap inside. It's a little wire coming up here. I just got a sharp pocket knife. I'm going to make sure I get all the way through that. Alright, that one is disconnected. See, the little wires here are loose, and there's two caps in here, and the common goes to this, which screws into the chassis. That's your ground. Either side of this goes to the AC line, so that is your return path. Your chassis goes through whichever of these is the neutral, and it finds its way to the ground. And then what we're going to do is we're going to heat this up a little bit with a heat gun, and then we're going to start digging it out. We don't need to go crazy. We don't need to put this on high and liquefy this. We're just trying to soften it a bit. If you get it too hot, you will start to fry the Bakelite. It's not indestructible. Heat will start to deteriorate it. Alright, let's give that it's saying it's not so hot I can't pick it up, but it definitely soft. See, this just starts coming out. So you just do this. And work your way around until you can get to the caps, and it'll pry them out. Might want to wear gloves when you do this, because this gets on your hands. It kind of sticks to your skin, and you'll need to get it off. Soap and water works to some extent, but you may need to do something a little bit more aggressive, like some Gojo or something. I mean, it is a tar-like substance, you can imagine. And the first layer's off, and now it's kind of cooled down, so it's getting harder to pick at, so we heat it some more. And this stuff tends to get all over. See how easily the stuff liquefies. I'll just put a little pile here, or I should say softens up. So they call it high temperature wax, but it melts at a pretty low temp. I mean, I have this on low, it's not all that hot. And as it gets liquidy, the oil or whatever that's in there starts coming out and will soak into anything and everything. And the smell, yeah, it smells like the tar you'd use on a rooftop. Now from our damaged one, I know exactly how big the caps are and where they are. They almost go the full length, and between the two of them they fill it up pretty well. So I can kind of start to see the tops of them already. When you do pry, if you pry to get them out, just go to this end where there's more material. Don't pry from this end, you'll just blow that end right out. Pry from this end. We're not there yet, but that's what I'm going to be doing when I get a little bit deeper, is go in here, try to catch the end of the cap with a flat bladed screwdriver and kick it out. You can see why some folks don't like to do this. There are other ways to do it, ways that are less messy. We're going to try one of them next, which I have not done before. This is the way I've always done it. It's messy, it's slow, but I've never broken a block doing it this way. And then of course I had to disconnect all the wiring. So all in all, to disconnect the wires, to get this out, to get the insides out, put new caps in, remount it, hook the wires back in. If I moved really fast and wasn't talking and making a video, 15 minutes, something like that. More for the other ones because they have more connections going to them, so figure 20-25 minutes times 10 blocks or however many there are. So yeah, it's tedious. Whatever there. There we go, that's one of them. Once you get one of them out, the rest will just come out real easy. So that's it. As far as the stuff left inside, yeah, if you really want to get it out, you can dig it all out. You can use paint thinner or acetone to dissolve this out. It won't hurt the Bakelite, but you don't have to get every last bit of it. It's not going to make a difference. I was kind of curious, as I'm seeing some metallic stuff in here, I'm wondering if one of these blew apart. It might have been for me digging it out too. So yeah, these are the caps. They are just rolls of paper and like aluminum foil. They got part numbers on them too. A little hard to see, but there's a 33 on there. Now if this was really bad, these would just have been blown apart. Let's see if we can see one of the old ones, or one of the other ones that did blow apart. It's still in here. Well, these didn't really blow apart, they swelled up. I don't know how well you can see that, but this bulged out to the sides. Not horribly. Certainly seen worse. Alright, so that is that. I'll show another technique on a different one. In fact, we're going to practice. Now that we've got a spare chassis, we got some spare blocks. We'll play around with those. Let's try another technique to get the insides out of one of these blocks. Now this is one I just took out of the donor chassis. We're going to pretend that this is still wired into the radio, and we just took out the bolt and twisted it around. The idea is, as before, we're going to cut off the little wires coming from the insides, and then we're going to poke the capacitor out from this side by going through those holes. Now you can make your own little tool kit to do this, but amazingly somebody makes a kit. I was just searching for something unrelated on eBay, and I saw somebody sells this nice little kit of Philco tools. An alignment tool. The one I showed earlier works just fine, where it's a wooden dowel with a plastic hex bolt stuck into it. But hey, I figure if somebody goes to the trouble to make this, I might as well pick one up and give it a try. This is unsolicited, unsponsored. I just stumbled across this on my own. Now these are the tools for getting a Bakelite block out, that's my understanding. And he has instructions on his eBay page on how to use these. So one is a drill bit and one's a poker. The drill bit, from what I read, you put in here and you twist it and it cuts that little wire. Wow, that does a great job. That'll work better than my pocket knife. Yeah, it's going to dig into the brass eyelet maybe a little bit, but I'm not going to worry about that. Yeah, that's it. Just one little twist and it cut right through it. Very nice. Yeah. Just double check. Oh, I might cut through one of them. Give it another little. There we go. Yeah, cut through all of them. And then you take this and you poke. Now it's probably not going to work too well now, because you really do need to heat this up a little bit. So once again with the heat gun. Remember, this is going to be in the radio. So imagine it's in the radio. We twisted it around a little bit. No, we don't have to twist it around completely. We could have nicked those wires while it was still bolted down, for that matter. But to get the insides out and put new stuff in, we're going to have to twist it a little bit. And as far as heating goes, you just want to get the sides. Just hang on to this resistor here while I do it. Again, this heat gun, it's on low. You use a hair dryer for this. It's not crazy hot. We just want to soften the edges so the block will slide out readily. I'm going to get this side too. So you're not going to be roasting the radio. Again, I'm not burning myself. It's getting a little bit warmer than ambient temperature. It's probably like 130 degrees, 140 degrees, something like that. And again, I have not done this before, so I don't know exactly how hot I need to get it for how long, but let's give this a try. And we are going to poke. Oh yeah, wow. Alright. Well, yes, that does work. That does work surprisingly well. And that took all of what, about 2 minutes, if that. Most of that was because I was talking. And this is not even warm, really. Just barely. It's pretty cool. Well, you can see there also wasn't a whole lot of tar in this one. The first one we took out had more in it for sure. This has some pretty beefy caps in it that filled up basically the entire tub. I think that also made our life a bit easier. But hey, how about that? And it's super clean inside. And then as before, we stick our new components in there, and if this was still in the radio, we would then just carefully twist it back around and put the bolt in, and we are done. Pretty cool. So I will try that in a bit on one that's actually in the radio, in situ, I guess you'd say, and not disconnect any wires. But first we are going to try powering up the radio with just that AC line bypass replaced, because I was told online that that should make a significant difference, so fingers crossed that it does. Alrighty, so what do we put inside of this? Now this block is different from all the others because it goes to the AC line, or mains voltage, the outlet in your house. Now in an ideal world, that would be a nice, clean, well-behaved sine wave. Reality, though, is there are going to be surges and transients and spikes. Imagine there's a lightning strike. You plug in the vacuum cleaner. I'm sure you've seen your lights flicker at times. This capacitor is before the power switch. The two caps in here are on the AC line 24/7. They better be able to handle it. Whatever was in here before, maybe it was more robust than the caps in the other blocks in this radio, but I don't think they were especially robust. I mean, we saw the one that failed. So what are we going to put in there? We really shouldn't use your standard plastic film capacitor like we're going to be using in the rest of the radio. We need to use something rated for being on the AC line all the time. You may have heard of something called a safety capacitor. I think that term is a bit misused, misunderstood. I'm going to include a link that goes into more depth about it because I want to get it right. What I can tell you is there are two specific types, X and Y. X is for across the line, going from hot to neutral. Y is going from hot to ground or neutral to ground. The Y tend to be beefier, more expensive, larger. I think it's because when there's a transient, if you're going from the hot to the neutral, I think the transient's likely to be on both sides of it. Versus when you go from, say, hot to ground, I think the transient will be on the hot side and the ground will be ground, and the capacitor sees a bigger spike. Again, I'm not 100% sure I got that right, but I believe that's right. Now, luckily, to help us with this confusion of different types and ratings and so on, there are some, like this, which has been my go-to lately, that are rated for both. So I can just grab one of these and be confident they can work either. Now, luckily, to make our life a little bit easier, there are types that are good for both, like this one in my hand, which has been... Now, luckily, to make our life a little bit easier, there are types that are good for both applications, like the ones in my hand. These are 0.01 microfarad, made by Vichy. The printing is small. I'm having a squint here, but I do believe it says Y2, and then a 300 with a squiggle, and X1 and 440 in a squiggle. What does that mean? There are different flavors, different grades of these, like Y1, Y2, Y3, X1, X2, X3. I believe the higher the number, the more robust it is. I could have that backwards, but that's what that number refers to, is the grade of it. Now, luckily, to make our life a little bit easier, there are components that are rated for both applications, like the ones in my hand here. Looks like a regular cap, right? But if you look close, there is an X1 and a Y2 on it. This is made by Vichy. I see 103, that's the value, so it's 10,000 picofarad or 0.01 microfarad. And then there, it's hard to read, Y2, 300 with a squiggle and X1 440 with a squiggle. What does that mean? That means in a Y application, Y meaning from one leg of the AC line to ground, it's good for up to 300 volts AC. The X with the 440 means if you're going right across the line, it's good up to 440. That's what I mean about the Y type being the more demanding application. How do we install these? Well, we're going to need two of them. We go inside, we got plenty of room, let's fit in there no problem, and we just go up through those eyelets. We can massage the component leads as needed with needle nose pliers, and we just wrap them around where the old ones were, and put this back in the radio and hook our wires back up, and we're done. Once you've got the insides out, it's pretty simple from there. Let's see, this is the original packaging. Yep, so here is the part number. I got this from DigiKey, apparently in 2014. I'm just about out, so I best get some more. Component selection, where to get them, and all that. That deserves its own video. I did one ages ago on where to get capacitors. It's probably 10 years ago now. I think it needs some updating. Suppliers have changed. New component types have come on the market. Here is that block, restuffed with two of the appropriate type of capacitors. Put a little bit of heat shrink tubing around that one leg as it can. It comes near the middle. Don't want any chance of those two shorting, because those are the two sides of your AC mains coming in there. So that is ready for installation. I tried to get some footage of myself installing the caps, but didn't come out too well. I will try again on the next block. That is going to go down in there. Gotta find my screw and washer, which I saved in my container. Never misplace anything. And then we can clean up some of this wiring. I do believe these two wires go to one of the lugs, and this goes to the other, and then we ground it through that screw. And remember, when you install these, for some, that star washer goes on top. On some, it goes below. In fact, most it goes below, including this one. So I need to get off the screw and then get it behind that block and then put the screw through, which would be darn near impossible the way I have it right now, because I can't. I need 4 hands. But what you can do, well, put it in place, and if you put a little bit of sticky something or another, you can hold that washer in place. Otherwise, get your screw and get it through there, and try to carry the whole thing over with the washer in place and get it in there. It helps if the chassis was tilted back towards me a little bit, and get it in that hole without the washer falling off. Helps to have nimble fingers. I think we've just about done it. Get over. Aha, we made it. And then I'll just tighten that down. Cap has been wired in. Got an antenna hooked up like before. It's about the same time of day. That does have an effect on AM broadcasting power.
Jersey after a bad game.
Wow, how did that make a difference?
That is a baseball injury if you've ever heard of one. You're about oh yeah.
Holy cow. This is with the volume all the way down. So these are some stations you were barely able to get in before. Let's go around the dial like we did before. Start at the high end. Let the volume about 3/4. By the way, I did confirm the volume controller should be 500K and it should be audio taper. I suspect what's in there is linear taper. We'll explore that more in a bit.
Zaburzenia mogą być mowy lub nawet rzucia, szybsze ścieranie zębów
Let's try out that
i
tone
na
control.
końcu problemy ze stawami skroniowo-żuchwowymi.
Pani doktor, jak działa aparat ortodontyczny?
Now that we have a lot more volume, I can hear there is a bit of a difference between all the positions.
Aparat ortodontyczny działa poprzez wywieranie nacisku na zęby, powoli przesuwając je w odpowiednim kierunku. W miarę wywierania nacisku kość w szczęce
Tone control again.
From the Chicago Takeover, every Saturday at 6 p.m. It's the Chicago Takeover.
Okay, one, I'm very impressed that made that much of a difference. Two, I'm very impressed at how much I'm picking up.
Swój adres. Być może kwalifikujecie się na zwrot i do wykorzystania.
Jak tylko zejdę z samolotu, tak i wyszło. W samolocie on ustроил
And then we do have a healthy Polish and Ukrainian population in the area. And Hispanic.
We believe that it's from the beginning to the end. It is everything from God to us. It is the
That gets
explanation.
painful. This is with the volume control all the way down. I can't get the volume any lower than that.
It's found in the
It could be because the volume control has issues, or it could be there's just enough crosstalk between the wires that it's radiating around underneath the chassis.
And he just could not make the play.
Again, volume control is
Yeah,
all the way
didn't seem
down.
to have a read on it very well off the bat. He was 2 years old at the time. And another one. And he would say, all right, you have this problem, this problem, this problem. Take a look.
That's WLS
It demonstrates pin tears.
coming in fine.
There's a lot of ways we might define that term.
820,
We posted the channels and contact information. Connect to our
WBBM
Odyssey
780.
915. Because
Now there is a station around 740, Zoomer Radio, I think it's called, out of Canada, that plays music. I can rarely get it in. I think at night it's easier to get in.
high demand, low inventory.
WGN.
Nothing will continue. It's Thursday night football. It'll be on.
670. You know, that dial scale is really accurate too. So there's 670, 720, I mean they are dead on. Let's check the higher end again. 1000's off a little bit.
We go to the bottom of
And going back the other way, finally. Not sure what that is. 650, 640 AM? Not much at the end of the dial. 560, I think, would be the end of it.
and it's a money-making operation, and it has no opposition.
Alright, so wow. Yes. Don't ignore that cap. In the past, I think I've said it doesn't matter. Oh, yes, it does matter. If this concept of grounding is a little confusing, maybe this diagram will help. Now, I am by no means an expert on radio transmission and reception theory, but this is how I understand it. So, on the left side, please excuse my crude drawings, but this is supposed to be the AM transmitter. So it's a little broadcasting shack, and that's the transmitting tower. Now with the transmitter, they have copper rods hammered into the ground. for the ground. And then the output of the transmitter goes to the top of the tower, and it's radiating out into space, into the ether, for all of us to receive. What this is supposed to represent is our long wire antenna strung between a couple poles, which would have to be insulated from the ground, which then feeds into the antenna terminal on what is supposed to be a Philco 90 radio here. Now to complete the circuit, so we got ground, we've got radiated RF, we're receiving it in our antenna, it has to get to ground to complete the path. So we've got to have this grounded somehow to get good reception. That can either be done by connecting a wire to the ground terminal in the back of the radio and connecting it to some metallic conductive something that finds its way into literally the ground. That could be a cold water pipe, that could be a metal rod hammered into the ground, or it can be our house wiring. So on modern outlets, we've got three terminals. We've got hot, we've got neutral, we've got ground. That ground literally goes into the ground. Somewhere on your property, that ground is in the ground. But the neutral does too, back at your fuse box or breaker box. So the neutral in your house is insulated from the ground wire, but they do actually connect together at some point. That's why, even though this radio, as originally designed, just has a 2-terminal AC plug, there is no ground, there's no third prong on that, but the neutral can act as a ground. Let's take a look at the radio schematic for a moment. Here are the antenna terminals. We've got a ground and antenna. Those are the 2 jacks on the rear of the chassis. And the ground, you see, just goes to this symbol. That symbol throughout the schematic, that is the metal chassis. Now, what's the antenna going to? It's going to a coil, the primary and the transformer, with a resistor across it. I think that is there to help absorb transients, say there's a lightning strike or something, to help so it doesn't blow out the coil. But the point is, this ground has to go to something. So you're receiving RF via your antenna. It has to conduct through this coil to ground, or it will not transfer it to the secondary. So this provides isolation from your antenna to the rest of the radio. If you don't have current flowing through this coil, it's not going to make it over to the secondary and then into the whole rest of the radio. So you've got to have a good ground. You've got to have a path for that energy collected by the antenna to flow through to the ground and make its way all the way back to the transmitter. Now, if we look at those decoupling, filtering caps on the AC line, so this is the plug going into the wall, non-polarized, so either side could be hot or neutral. You don't know. You can plug it in either way. And that's why they got a cap on both sides. So yes, these caps will help filter out noise, but I think really their primary purpose is to provide a path to ground. Because at RF frequencies, these caps look like a short circuit. So as far as radio frequencies are concerned, all this is shorted together. Both sides of the plug shorted through the cap, going to the chassis. So that is how your radio is grounded through the plug, going through your house wiring all the way back to the earth.